Alright guys, this is question 12 of the 2018 AMC 10 Test A. And this is also a challenging problem, and it starts to get more challenging at like question 10 or something, but this one was I got a little messed up on this a little bit, but I ended up figuring it out, which is good, alright? So, and you'll figure it out too. So the question is asking us how many ordered pairs of real numbers x and y satisfy the following system of equations. And the system of equations is x plus 3y equals 3, and the absolute value of x minus, or the absolute value of the absolute value of x minus the absolute value of y is equal to 1. Now, so this first problem here is easy, right? And we want to put it in. It's not asking us which exact points, right? It's not giving us an exact point like 3, 1 or something. It's just asking us how many points, all right? So therefore, we can just make a graph here. We're making a graph. And we can just roughly sketch out. We don't need to exactly match the points, all right? So let's if we want to draw a rough sketch, we're gonna have to isolate y in both equations. And let's start with this first equation first. It's pretty easy. You get 3y is equal to minus x plus 3. You divide 3 on both sides, and you get y is equal to 1 over 3 x, negative 1 over 3x plus 3. Or plus 1, I'm sorry, because you divide 3 on both sides. And now let's draw this line roughly, okay? So we have, let's say our 1 is right here. All right, the number 1 is right here. And let's draw here, I'm going to draw in a different color, actually. Choose the color red right here. It's a bad line. Alright, this is our line right here for our first equation right here. Now let's try to find the equation for the second one, alright? So let's go back to our absolute value rules, alright? So our absolute value rule says that the absolute value, when the absolute value of x is equal to a, x is equal to a, and negative x is also equal to a. Or I'm sorry, not negative x is equal to a. We could just rewrite that as x is equal to negative a if we just multiplied negative 1 on both sides. Alright, so we have that. So let's work this out now. So if we have let's start with this first absolute value one first. So we have the absolute value of x minus, alright, the absolute value of y is equal to 1, alright, following this one right here. And then we also have the absolute value of x minus absolute value of y is equal to negative 1, alright? Because we're just following this one right here now, alright? Now we want to isolate y on both sides of the equation, right? So we're going to add absolute value of y on both sides and subtract negative 1 on both sides, or subtract 1 on both sides simultaneously. So we have the absolute value of y is equal to absolute value of x minus 1. Same thing for this one right here. We have absolute value of y is equal to absolute value of x plus 1. And now that we've isolated our y here, we also want to change it back into this form right here because we don't want this absolute value for y right here, right? So then we're going to change that to here. Let's erase this real quick. Alright. So then we're changing that into, we're going to change this one first, right? This one will have two equations. So all we're doing is just following these rules right here, right? So then we're changing it to y is equal to regular absolute value of x minus 1, and also plus, or the negative value of that. So just 1 minus absolute value of x. Alright, this one matches with this equation right here, right? Now we're going to match it with this equation right here. So let's bring this all the way down here, alright? So the two equations for this one, we're just going to follow these rules again. We're going to have y is equal to the regular one, so absolute value of x plus 1, and also the negative version of that. So y is equal to, I'm going to distribute the negative to everything. So negative absolute value of x and negative minus 1, all right? So these are our 4 lines that all contribute to this one function right here, all right? So let's draw out all of these lines. Is it still work? Yeah, it is. All right, I thought I muted myself for a second. All right, now let's draw these lines out. So I think we should use green now. So we're gonna use green. So let's graph this first one right here. So we have y is equal to the absolute value of x minus 1, all right? So we're going to get absolute value of x minus 1, so that means we shift the function down 1 time. We're just going to draw a rough sketch of it, all right? So this is how it might look like. Obviously, it's not perfect, all right? So here we already see we have 2 points matching, all right? So we can just cross out number 1 right here. We have 2 points matching, all right? And over here, we're going to have 1 minus the absolute value of x. So if we get minus absolute value of x, that means we reflect the function down right here. We're going to add, so if we had 1 right here, so that's our absolute value of x reflected, all right? And it's telling us to add 1 to it, all right? Shift the function up 1 unit. So this is how it might look like. And there we go. We see 3 right here, right? So let's cross out the number 2, right? So we have 3 shared points. We have 1, we have 2, and we have 3, all right? Let's try out this one right here now. We have y is equal to the absolute value of x plus 1. Absolute value of x is just something like that, and then we shift it up 1, so we're going to shift it up 1 right here. And there we go. That's our third line, right? That's our third absolute value function right there. And be careful not to count this as a fourth intersection right here, right? Because remember, all of these absolute value signs, or all these absolute value lines, contribute to this one function right here. So all of these lines are just one function, all right? So when we say that this line shares 0, 1 with the absolute value function right here, although it may cross 0, 1 at more than one of these lines, ultimately all of these lines contribute to this function right here. Okay? Or all those absolute value functions contribute to this right here. Alright, so let's do this one right here. Let's do negative absolute value of x, so this thing right here, minus 1, so we subtract it down 1, and we'd have something like this. And we see that it does not intersect this at all. So here we have our points right here. Let me change the color to, let's get yellow right here, right? So we have one intersection right here. Remember that when it intersects these two, it's just going to be one intersection because these two are both the same into this function right here. It contributes to this intersection right here and this intersection right here. So what is that? That's 3 intersections, all right? So 3 ordered pairs that we don't know, but we know that it crosses 3 times. And look, we have an answer right here. The answer is going to be C because it crosses 3 times, which means that there are 3 ordered pairs. All right. So remember, one of the hard things to remember about a problem like this is that when you're doing absolute value functions like that, remember that they all contribute to one function, all right? Even though there may be more than one line, it all will ultimately contribute to one function. There you go. That's how you do the problem.